Hey, this is Josh, and this is part 2 of the Cardano Plutus smart contract tutorial series. In this video, we're going to go over the starter project on the Plutus Playground. Everything in this video will be built up on our previous video, the Hello World program, which you can see in the suggestion above, where we learned about contracts and schema definitions. In the Hello World project, we've only defined a basic contract and we didn't really send anything across the network. Well, in this specific starter project, we're going to go from taking inputs from the user all the way to using that input and locking and redeeming ADA from the network. As you can tell by looking at the timeline of this video, it's going to be quite long. At the end of this video, you'll have a strong idea of how to build your own Plutus smart contract, and then you'll be able to look at the code of other Plutus applications and have an idea of what's happening. All right, now that we're done with the Hello World program, let's look at the starter Plutus app. So the high level of this app is that it's basically just scaffolding for you to build your own Plutus app. It just has the minimum information that you need. Things that you need to change is a datum and a redeemer value type, and we'll talk more about those later. And the important thing in this script is that there are two endpoints that are implemented, publish and redeem, which has existing functionality. I'll show you what these endpoints are later in the simulator. Now, if we quickly go through the code, we see we import our Haskell functions. We define these types, datum and redeemer, which we don't know. We have these functions that we don't really quite know, more functions that we don't know. But the first thing we do identify is we see our schema definition, and we know what that is. That's basically how a user interacts with the blockchain. And just like what we said earlier, we have a blockchain action, and then we combine them with these two additional functions or endpoints, publish and redeem. We'll look into more what they do later, but notice that publish takes in a tuple, or basically two types, a integer and a value, and redeem takes in a integer. So we'll look at that later. We see a contract, and this contract has publish, select, and redeem. If we look at what publish and redeem is, they are two functions that return a type contract, so these will be important later. They also has the word publish and redeem, which is defined in our schema. And continuing down, and then finally we see that we have endpoints, which remember, this is how Plutus knows what to show to the user. It has contract, which is what we define here, where we have this function public, select, redeem. We'll talk more about that. And then after we set our endpoint, we set our MK schema definition to be the new schema we defined for this specific project, and we call it MK known currencies. I will tell you ahead of time that there is actually an error in this code that we have to implement. We'll talk more about what validate spend is later. But when this function gets called, it returns a type error, and there's a comment that says, please provide implementation. So ignoring all of this for now, let's go to the simulator. So we hit simulate. Plutus already gave us a example set of actions. However, if you look in our wallets again, you'll notice that we have some new available functions, publish and redeem, which are the exact endpoints that we implemented in our schema. And if we look at what publish does, it takes in two values. It takes in an integer and a value, which in this instance, a value is just the ADA that you're trying to lock up, and an integer is just a number. Now, if we look up redeem, we'll notice that it only takes in one integer, which is in this case 1, 2, 3, 4, 5. And so this is how in our schema we can define endpoints where a user can give us different inputs like numbers, strings, and how we can use them to do some smart logic with our Plutus contract. Now let's quickly evaluate. And so what this code do is it will lock up 25 ADA from wallet 1, so this will bring it down to 75. And then, oops, oh, the code's gone. And then wallet 2 will try to take the money by guessing the magic keyword, which was 1, 2, 3, 4, 5. So what happened here is wallet 1 did lock up their 20 ADA, but wallet 2 failed to take it out. And if we go into our logs and see what happened, we can see that for wallet 1, it successfully locked up their ADA, no problem, the 20 ADAs. However, in wallet 2, when we try to redeem the ADA, we can see right here our redeem function, we run into a script error, a evaluation error. And that's the error that I pointed out to you guys earlier. And we're going to fix this near the end of this video. So that is basically what happened here. Before we jump back into code, let's look at the high-level concepts that we need to understand before we can try and reason about what is happening in this code. In the Hello Road project, we never had to transfer or lock any ADA. We only create a contract that printed out a string. That is not the case in the Starter project. In the Starter project, we now need to actually lock ADA. And to do that, we need to use something called a validator script. And a validator script is basically the code that we use to lock and unlock a transaction on the Cardano chain itself. We'll talk a bit more about how we do that later. So the script that we'll use for Plutus will take in three types: a datum, a redeemer, and a validation context. A datum is essentially just the data that a user sends to lock their ADA. It can be just the amount that they're trying to lock and the validation or some form of validation. In this example, it was just an integer that we use to lock it. A redeemer is very similar to the datum. It's a data type that a person who's trying to unlock the ADA that's being locked sends to confirm if it is correct. And if it is correct, the redeemer will receive the ADA input. And then finally, we have the validation context, which is just information of the transaction itself. Now, one thing I want to turn our attention back to is validate spend that was implemented in the Starter project. This is our validation script. It takes in the custom myDatum, myRedeemer, and the validator, and then it returns a Boolean, whether or not the transaction succeeded or not. In the implementation of this function, we still need to implement it, but we are given these types, and we give an error, which is not what is expected. What we should do for our implementation is to say if our datum is the same as our redeemer, then clearly the redeemer who's trying to get the money that the original sender locked up is the correct person because they knew the password, in theory, and then this should return true. And we'll implement this later, but in the meantime, let's look at some of the other code that was introduced in the project. Before we move on to another concept, I want to take a deeper look into the data types that we talked about for our validator script, specifically the myDatum and the myRedeemer, which, as you might suspect, is our datum and redeemer that we send to the validation script. So when we say a new type, it really means create a new object. And specifically, this new object would be of type integer. Actually, both of them are type integer. And that essentially is what new type actually means. It means I'm taking an existing object, such as integer, and then I'm wrapping my own data structure on top of it. We have the words deriving new type Plutus tx.isData. You can think of deriving as extend, if you're familiar with Java or JavaScript, where we are extending the existing functionality of Plutus tx.isData. Now, what is data? We'll take a look into it later, but essentially data is just a generic data structure that Plutus invented that has some special capabilities that allows basically to wrap our type, myDatum, myRedeemer, into a generic form that we later send on to the blockchain, which would then understand what the type is. If we were to look at a different language equivalent of this, this would be something like public class myDatum extends Plutus, and we'll just say data for simplicity. And then inside a constructor, public myDatum, we will receive a integer. And we will have a private field I, which is an integer. And then we set that to our type that we receive in. And that's basically all we're doing here. The data that we extend is just a way for Plutus Core, which we'll talk about later, to understand what our constructor is later when we lift it. There's a great article in the Plutus documentation that talks about data types and datum and redeem, and I'll link them in the description below. A quick recap. Remember that our Plutus TX data type came from the module language.plutustx. And inside this language, we called the isData type. This isData is basically an import that this module made from the language Plutus tx.isData that we re-exported out for us to use in the Plutus Playground. So what's in isData? Well, if we go back and look at our files, we see that isData has its own file, the isData module. And in here, we have 3 instances, class, instance, and th. So if we go find the isData folder, which is right here, we can look at class, and we can see essentially we have this isData that we used in our code where we derived. And what we see right here is that A is basically a type. We don't, which is the integer that we passed in. We don't really care what type is. We just know that it's a type. And what we do is when the toData function is called, with the given structure A, we just return data. And then if you look at what data is, if you go look at language plus tx.data, we see that data is a generic type, inherits all of these functionalities and have these class. Quite frankly, I'm not too sure what it is, but here is where you can find it if you're curious. So earlier we talked a bit about on-chain versus off-chain. If you looked into the documentation a bit, you might see the words Plutus Core and Plutus TX. There are 2 ways that we write Plutus code. There's the, you can think, client side, where we just write the Haskell code, which represents our desktop or our wallets that send the data out, or specifically sends out the transactions to the blockchain. So that's written in Haskell. One interesting problem that Cardano wants to solve, from my understanding, is that they want to be able to use the same Haskell code to be able to also run the Cardano blockchain itself, which is what essentially Plutus Core is. And so to accomplish that, they use something called Plutus TX, which I assume TX stands for Plutus transaction. And what Plutus TX is, it's essentially just a set of libraries and compiler that converts the Haskell code that we write into Plutus Core, which is the on-chain being on the Cardano blockchain itself, that we use for a contract application. A quick example of that is our validator script. The validator script that is written is actually converted with Plutus TX to form a Plutus Core code that will later be used to handle transactions. Now, Plutus Core is essentially just the programming language in which the Cardano blockchain runs on. So I like to think of it as maybe the assembly code where Plutus TX breaks it down to the smallest, most efficient code. But all we need to know is that Plutus Core is a separate language that's based off of Haskell, which then is run on the Cardano blockchain. Now that we understand a bit more about what Plutus Core is and what Plutus TX is used for, we can talk a bit about template Haskell. Essentially what template Haskell is, it's a meta programming feature that Haskell has that Plutus TX uses to convert our code to Plutus Core. What it does is it takes the code that you've written, and then during compile time, it might actually change the code that you write to have different types, specifically maybe convert it to Plutus Core. Now, if that made no sense to you whatsoever, no worries, you're in good company. The important part to understand for when you're writing your own smart contract is that essentially you'll be using these 4 boilerplate code, and you'll see them over and over and over. So the first thing we see is that when we define our datums and our datum and our redeemer, we see that one part I didn't talk about earlier is this make lift. Without going too much into detail, essentially what make lift is when we are sending our data from Haskell over to Plutus Core, when we lift the data type, it's essentially just a way for us to tell Plutus TX what the data type is so that it can be used both in Haskell and in the external Plutus Core code. And we do the same thing for our redeemer. So anything we want to send over to Plutus Core, specifically in our validator script, we need to make sure to lift it. The next thing we need to include is a script type. And all the script type is, it's just a way for us to define our redeemer and datum, which we'll use later in our starter instance, which is here. And then of course we have our validator script. I think we talked about this enough. And then now we're back to the starter instance. Once again, also without going much into the details, the starter instance is essentially the compile Plutus code that we'll be using later to send a transaction across the network. It might look like there's a lot of complex syntax, but most of this is actually just copy and paste. We just give it the script type that we've instantiated, where we define our datum and our redeemer. We give it our validator script that we've written, and then we just define our datum and redeemer type under the variable name wrap. That's all we need to do for our start instance, which then we'll use later on to send a transaction across the blockchain network. I won't go into more details, but if you are really curious about template Haskell and how all of this works, I will also add a link to the documentation that talks about Plutus TX and template Haskell in the description below. Now, the final piece of the puzzle before we move on back to the code is that we want to understand endpoints, specifically the ones that we define inside our blockchain action. We have both publish and redeem. Remember, our endpoints is a way for us to write a function that would return a contract, which includes the schema that we define. And what Plutus would do with this endpoint is that it would create the actions of the code that we defined, which, as we saw earlier when we defined publish and redeem inside our simulator, we were able to give the user inputs. So a common pattern in all the examples is that we will pass another function into our endpoints, which in this case is contract. If we look at our contract function, it returns the exact same data type, and in its definition, it says publish, select, redeem. This is just a smart way of using the function select with the two functions that we define, publish and redeem. Essentially how this code works is if the user makes a publish action, we just run the publish implementation. Otherwise, if they use the redeem action inside the simulator, we run the redeem code. So if we take a quick look at redeem and publish, you'll see that they both actually return the same contract type that we expect in our endpoint. And the really cool part of both of these functions is that if you look over here in our do statements, this is actually where we define the logic of our smart contract. Generally speaking, in all of these endpoints, we want to be able to send a transaction, which is, you see right here, submit TX, submit transaction constraint spending, submit transaction constraints, and we would send these transactions to the Cardano blockchain, which then will store ADA from our wallets. Generally speaking, every endpoint will send a transaction. Cool things that I want to point out in this code is that notice that we have our publish and redeem endpoints that we defined. Their publish has two data types it takes in, and redeem just has one. In the first line of each of our redeem and publish function, and you notice that in publish we have an integer and a value. If we use the left arrow, which basically just means take out whatever value is in our endpoint, we can define two parameters, I and locked funds, which represents an integer and a value. Now, what's really cool about this is that now we actually have a way to take the user's input and use them for something. And of course, that something usually involves creating a transaction and then sending said transaction to the Plutus blockchain. Now, at this point, we know enough to actually go through the code and understand what's happening. So before, when we saw this, we see this new type, myDatum. All we're doing is we're just creating the datum and the redeemer that our validator script needs so that we can unlock and lock ADA on the blockchain. And then of course we need to lift it so that we can compile this code into the Plutus Core. In the next line, on line 34 and 35, we have our validator script, and this is just how the Plutus Core figures out if the person who's trying to redeem your token is actually the person who they say they are. And we need to go back and we need to re-implement this because right now it just throws an error. Contract address, this is just a function that returns a address, which is something that Plutus gives us. It's just the address of a blockchain. You can kind of think of it as a static function that just returns the address. We can call it anytime we want. We won't go into the implementation, but there's a existing ledger.script address function that we get from Plutus, specifically, actually it's probably from over here, script address. And all it takes in is just our starter instance, which we define down here. Now, we also need to create our script type, which we use our compile validator. All we're doing here is we're just setting up our redeemer and datum type, and that's it. And then finally, we define our compile validator, which we already talked about. It's just a boilerplate code. We just give it our starter script. We give it the validator script, and we give our wrap function, which just tells our validator script, like, what the datum type and the redeemer type is, and that's it. So first we need to define our schema for our contract. Now, remember we have our existing blockchain actions, which is just a combined list of all sorts of other endpoints and effects that came with Plutus. But what's different in this project is we actually defined two of our own endpoints, publish and redeem. And remember, if we were going back in our simulator, publish took in two variables, our password that we wanted to use to lock and the number of ADA we want to lock. And then our redeem takes in an integer, which is the password we want to unlock that ADA. And now we look at our contract. Remember, our contract is the function that we used in our endpoints, which is what the playground uses to show the UI of all the available functionality that our code has. And so what contract does is publish, select, redeem. This is actually just a Haskell syntax to say select, publish, redeem, but this just looks more elegant, I guess, so to speak, more readable. Based off of what the user inputs, we either call the publish function, which is defined here, or the redeem function, which is defined below that. We can only do one code, and both of the function returns a contract scheme E void. And remember what this means. This function, all these functions, wants to return a contract object that takes a schema, which we just call schema, and it returns E, which in this instance is a as contract error. So if something goes wrong, we return E. Otherwise, we return the type void. So we return nothing. And so let's quickly look at the implementation of our publish and our redeem. So publish has the same method signature as contract and as our endpoint. We just return a contract. But here we have our first implementation. What do does is basically it just says execute the code line by line. The first code, we extract the values inside our publish endpoint. So remember, publish gives us an integer and a value. And so we call these two variables I and locked funds. Then we need to create our transaction. Scott in our previous video already went into the implementation of must pay to the script, so I won't do it again. However, we call this function, and then we'll store the datum, which can be anything, which we define what we do with it in our validator script on line 35. And then we also send the locked funds, which will in turn take the value from our wallet. And so now that we have a transaction, we need to submit it. So what this line does is we call submit transaction constraints. So this is just another function we import, and it takes in our starter instance, which is our Plutus Core code that will run our script validator and everything else. And then we'll just give it the transaction that we've created. So this will store that datum, which is our password, and it will take the fund that that the user inputted from that wallet, and we submit it. What this void $sign means is basically void is a function that just returns void, and so a $sign is just parentheses. So you can think of saying something like get complete this transaction first, get that return type, and then give that return type to void, and that's all it does. And so this is how we publish something. We just take the two inputs that the user gave us, their password and their funds, and then we just create a transaction to store the data and take the funds, and then we submit it, and that's it. Next, we have redeem. Redeem has the same method signature, and in its implementation, we get the redeemer value, which is the redeemer's guess at what the password is to unlock the ADA. And there's this function called utxoadd, and we give it the contract address. This function utxoadd is just a way to get all the unspent ADA or the locked ADA inside the specific address that we're given. And this address, if you recall, if we scroll up, is just a function that received the address of the script, our starter instance specifically, that we set up earlier. So what this code is saying is give me all the locked ADA at this specific address, which is where our node is. So now that we know how much ADA we have unspent, we cast essentially our redeemer value into our redeemer data type. Essentially, we're boxing it up to be that data type because we need to send my redeemer over. We can't just send a number over. And so we just save that as a variable called redeemer. Let is just a syntax for variables. If you're familiar with JavaScript, it's essentially the same thing. So we have our redeemer, my redeemer type. And now we need to create our transaction. Another function that Plutus gives us is called collect from script, which, as you might imagine, we collect our ADA from a specific location. And we give it the unspent outputs. It's not actually an integer. It's actually more than that. It's an integer and an address, as I believe. So we're saying collect all the money from that address. And we will also give it our redeemer object, which will be used later in our validator script to ensure that this isn't a malicious user. And then we get our transaction type. And then we do the same thing. We return void because this function expects void. And we just call another function that Plutus gives us called submit transaction constraint spending. We give it the instance, the unspent output, and the transaction itself. And then we submit it. And if everything works out great, the redeemer will get the ADA. Let's go back to our validator script. Currently, inside our code, it actually doesn't do that. Reading our function, what happens is we return a boolean true to mean that the redeemer succeeded, and false to say that this is a malicious user and we should not unlock the ADA. In our implementation right now, we have 3 variable types that we define: my data value, my redeemer value, and just underscore. Underscore just means that this variable is not being used. Now, in the actual implementation, we just throw an error, which is what we probably saw earlier inside our simulator. So we need to actually implement this. Essentially, it's straightforward. If the data value we're given, our datum, is the same as the redeemer value we're given, then we would assume that the user is not malicious and we just unlock the ADA. To do that, we just update the code. We define our 2 data, and all we want to check is to see if they're equal to each other. Because remember, their underlying is that they're both integers, so we can just compare to see if the integer values are the same. If they're the same, unlock the code. If they're not, then this is an invalid transaction. So let's compile our code quickly. Oh yes, I spelled it wrong. My redeemer. All right, now let's try again. Let's compile. Okay, compiled successfully, and let's go back to simulate. All right, so back in our simulator, let's just hit the evaluate again. Remember, wallet 1 is publishing 20 ADA with the password 12345, and wallet 2 is redeeming those 20 ADAs. So now our transaction is finished. Let's go look at and see what happens. So here we go. Wallet 1 now has 80, and before, if you might recall, wallet 2 had 100 because we crashed, but now it has 120. And then if we go back down and look at our logs, we can see that for wallet 1, we published our transaction. It has the value 1245, and then it has the 20 ADA. And then in slot 2, our second action, our wallet 2 redeemed it. It gave the password 1245, and then it was able to successfully redeem the ADA, unlike last time where it crashed because our validator script just threw an error. Hey, great work we're making to end this video. I'm sure it was not easy or short. Now, at this point, after going through the starter project, we should have a very strong idea of how a basic Plutus smart contract is structured. We start off by defining our schema, which includes the endpoints that we want to get inputs from users. And then we learn how to write functions to extract those endpoints from the user, and then use them to send a transaction to the network. We send those transactions by creating a validator script, which uses a datum and a redeemer value, which we later use to check if the redeemer gave a valid input or not to redeem ADA. And then finally, we learned how to use Plutus TX to transform our Haskell code into Plutus Core so that our blockchain can actually use it. Now, if you found this video helpful, it would mean the world to us if you hit the like button below and maybe even hit the subscribe button to get notified of our next video. We will be going through the guessing game project on the Plutus Playground. But until then, I'll catch you in the next video and have a great day.